Hi friends, this is Murali Krishna Rao Daneti. Today we are going to discuss very important topic, that is properties of arithmetic progression. Properties of arithmetic progression. First property, if A, B, C are in arithmetic progression, first one, if A, B, C are in AB, that means if three terms are involved in arithmetic progression, what they will happen means, observe here, in an arithmetic progression, the difference between any two consecutive terms is always same. That means A2 minus A1 is nothing but A3 minus A2. Here A1, A2 and A3. A2 minus A1 is nothing but B minus A. A3 minus A2 is nothing but C minus B. If you transpose minus B from RHS to LHS, it will become plus quantity. And if you transpose minus A from LHS to RHS, it will become plus A. So, B plus B is equals to A plus C. B plus B, 2B is equals to A plus C. 2B is equals to A plus C. That means if three terms are involved in arithmetic progression, then 2 times of its middle term is equals to the sum of the first and last term. Sum of the first and last terms. 2 times of middle term is equals to the sum of the first and last terms. How they will ask the question in IIT standard about this property is, observe here, example, if 1 comma 1 by 2 times of log 3 power 1 minus x plus 2 to the base 3, comma, log 4 times of 3 power x minus 1 are in arithmetic progression, are in AB, then find x. Then find x. 1 comma 1 by 2 times of log 3 power 1 minus x plus 2 to the base 3 and log 4 times of 3 power x minus 1 to the base 3 are in arithmetic progression, then find the value of x. Solution, observe here, if we know that if three terms are involved in arithmetic progression, then 2 times of its middle term is equals to the sum of the first and the last terms. So 2 times of its middle term is nothing but 1 by 2 times of log 3 power 1 minus x plus 2 to the base 3 is equals to the sum of the first and the last term. That means 1 plus log 4 times of 3 power x minus 1. Observe here, 2 get cancelled. That is equals to log 3 power 1 minus x plus 2 to the base 3 is equals to 1 can be written as log 3 to the base 3 value 1. Our convenience here, this is 3. So, our convenience 1 can be written as log 3 to the base 3. So, here log 3 to the base 3 plus log 4 times of 3 power x minus 1 to the base 3. Here log 3 power 1 minus x plus 2 to the base 3 is equals to, observe here this pattern, log a plus log b is nothing but log ab. That means log 3 fourths 12 times of 3 power x 3 into 1 minus 3 to the base 3. If log a is equals to log b, then it is possible if and only if a is equals to b. That means 3 power 1 minus x plus 2 is equals to the 12 times of 3 power x to the minus 3. Here a power m minus n is equals to a power m by a power n. So 3 power 1 minus x can be written as 3 power 1 by 3 power x plus 2 is equals to 12 times of 3 power x minus 3. Let us assume that 3 power x is equals to some constant t. Let us assume that 3 power x is equals to some constant t. So if you substitute 3 power x value in this equation, we get 3 power 3 by t plus 2 is equals to 12 times of t minus 3. If you do LCM, 3 plus 2t by t is equals to 12t minus 3. If you transpose t from LHS to RHS, it is a division quantity, it will becomes multiplication quantity. That means 3 plus 2t is equals to t into 12t, that is 12t square, minus t into minus 3, that is minus 3t. So 12t square minus 3t transpose LHS to RHS, plus quantity becomes minus quantity. So minus 3 minus 2t is equals to 0. 12t square minus 3t minus 2t minus 5t minus 3 is equals to 0. This is, we will get quadratic equation. If you factorize this one, 12t square into minus 3, we get minus 36t square. If you split the middle term, 9 fours 36, that means minus 9t plus 4t. That means 12t square minus 9t plus 4t minus 3 is equals to 0. If you take 3 as common here, 3t, we get 4t minus 3 plus 1 as common, 4t minus 3 is equals to 0. If you take 4t minus 3 as common, 4t minus 3 as common, we get 3t plus 1 is equals to 0. If we know that 0 rule, if a into b is equals to 0, either a is equals to 0 or b is equals to 0. That means 4t minus 3 is equals to 0 or 3t plus 1 is equals to 0. We get t is equals to 3 by 4 or t is equals to minus 1 by 3. We know that 3 power x value always is greater than 0. Why? Because logarithms can't be determined for the negative values. So 3 power x value always greater than 0. So we take t value as positive 3 by 4. So 3 power x is equals to 3 by 4. We want x. This is exponential equation. We convert it into logarithmic form. Then x is equals to log 3 by 4 to the base 3. We know that if a power x is equals to n, then x is equals to log n to the base a. So x is equals to log 3 by 4. It is in the form of log a by b. Log a by b is equals to log a minus log b. That means log 3 to the base 3 minus log 4 to the base 3. Log 3 to the base 3 value 1. So x is equals to 1 minus log 4 to the base 3. Next, second property. Okay, second property. Second one. In an finite AP, we know that finite AP means it has finite number of terms. In an finite AP, the sum of the terms which is equidistant from the beginning and end is always same and is equals to the sum of the first and last term. That means if a1, a2, a3, a4 and so on, an minus 3, an minus 2, an minus 1 and an are in arithmetic progression, the sum of the terms which is equidistant from the beginning and end is always same and which is equals to the sum of the first and last term. We here second term, from the beginning second term a2 plus, from the end here second term is an minus 1 is same as here from the beginning third term is a3 plus, from the end third term is an minus 2 is same as from the beginning fourth term is a4 plus, from the end fourth term is an minus 3 is equals to is same as the sum of the first term and last term. Sum of the first term and last term. How they will ask the question about this property means, for example, if a1, a2, a3 and so on, a24 are in AP and a1 plus, a5 plus, a10 plus, a15 plus, a20 plus, a24 value is 225. Then find the value of Then find the value of a1 plus a2 plus a3 plus and so on plus a24. We know that the sum of the terms which is equidistant from the beginning and end is always same as and is equals to the sum of the first and last term. Observe here a1 and a24, a1 plus a24, a1 plus a24 is same as a5 plus a20, a5 plus a20 is same as a10 plus a15. So this can be written as three quantities are equal. So this can be written as 3 times of a1 plus a24 is equals to 225. If you transpose 3 from LHS to RHS, it will becomes division quantity. So a1 plus a24 is equals to 225 by 3. Then a1 plus a24 is equals to 75. We want their sum. We know that Sn is equals to n by 2 into a plus l or a plus an. That means Sn is equals to n by 2 into a, first term is nothing but a1, and last term l is nothing but last term is a24. That is equals to Sn is equals to your number of terms. How many number of terms? 24. So n value 24 by 2 into a1 plus a24 value we get 75. Substitute here 75. 2 ones are 2 12s. So Sn is equals, that means Sn is nothing but S24 is equals to 12, 75 is a 900. Okay. Next, third property. Nth term of arithmetic progression is n and its nth term is m, then m plus nth term is nothing but 0. That means nth term of arithmetic progression is n and its nth term is m, then am plus nth term is always 0. Very, very important property. Nth term of an arithmetic progression is n and its nth term is m, then m plus nth term is always 0. Observe here, am, we know that an is equals to a plus n minus 1 into d. Am means a plus m minus 1 into d. So am is equals to n, that means a plus m minus 1 into d is nothing but n. A plus m into d, dm minus d into 1, d is equals to 1. This is equation number 1. Also, an is equals to m. An is nothing but a plus n minus 1 into d. So, a plus n minus 1 into d is nothing but m. A plus dn minus d is equals to m. This is equation number 2. If you subtract 1 minus 2, a plus dm minus d is equals to n, a plus dn minus d is equals to m. If you subtract the equation, second equation, signs will be changed. So this is minus, this is minus, this is plus, this is minus. So a get cancelled, dd get cancelled. So dm minus dn is nothing but n minus m. If you take d as common, m minus n is equals to, if you take minus 1 as common, it is m minus n. So m minus n get cancelled, d is equals to minus 1. D value substitute in equation number 1. Equation number 1 is a plus d times of, a plus m into minus 1 minus of minus 1 is equals to n. So m into minus m is nothing but minus m. M into minus 1 is nothing but minus m. Minus into minus plus 1 is equals to n. So we want a is equals to, if you transpose minus quantity becomes LHS to RHS, it will becomes plus quantity will becomes negative quantity. So m plus n minus 1. Here a value is m plus n minus 1. This is the first term and this is the common difference. D is equals to minus 1. We want am plus n. Am plus n is nothing but an is a plus n minus 1 into d. Am plus n is a plus m plus n minus 1 into d. a plus n value, here m plus n minus 1 into d. So here we get a value, how much? M plus n minus 1 into d. Substitute here m plus n minus 1 plus m plus n minus 1 into d value here minus 1. So that is equals to m plus n minus 1 minus 1 into m minus 1 into n minus n minus into minus plus 1. So m get cancelled, n get cancelled, minus 1 plus 1 get cancelled. So it will be 0. So very important property. Mth term of an arithmetic progression is n. Its nth term is m. Then m plus nth term is always 0. For example, a fifth term is 7, a seventh term is 5, then a 12th term is always 0. A fifth term is 7, a seventh term is 5, then a 12th term is always 0. Or a 2020 term is 130 and a 130 term is 2020. Then a 2020 plus 130 is nothing but 2150. 2150th term is always 0. Very important property. If mth term of an arithmetic progression is n and its nth term is m, then m plus nth term is always 0. Next, fourth property. A mth term is same as third property. A mth term is n. This is also very important property. A mth term is m. Then a pth term is always m plus n minus p. Very important property. If mth term of an arithmetic progression is n and its nth term is m, then pth term is m plus n minus p. Then its pth term is m plus n minus p. How means? Already we know that am is equals to n and an is equals to m. Then common difference d is equals to, we get minus 1 before property, and a value is m plus n minus 1. Okay, we want a pth term. A p is nothing but a plus p minus 1 into d. If you substitute here a value m plus n minus 1 plus p minus 1 into here d value minus 1. So that is m plus n minus 1 minus 1 into p, that is minus p, minus 1 into minus 1, that is plus 1. Plus 1 minus 1 get cancelled, that is a plus n minus p. So mth term of an arithmetic progression is n and its nth term is m, then its pth term is always m plus n minus p. Okay, for example, a fifth term is 7, a seventh term is 5, then a 20th term is a fifth term is 7, a seventh term is 5, then we want a 20th term. So a 20th term is, we know that a n is equals to m and a m is equals to n, then a p is equals to m plus n minus 1. So m plus n, that is 7 plus 5, minus p, that is 20. That is 7 plus 5 is nothing but 12 minus 20, that is equals to minus 8. Very important property. Next, another example. For example, example 2. If a 107th term is 52, a 52 term is 107, then a 100th term is how much? Then a 100th term is how much? So we know that a pth term is m plus n minus p. So here m value 52. So a 100 is equals to m value 52 plus n value 107 minus here p value 100. So a 100 is equals to 52 plus 107 is nothing but 159. 159 minus 100. So a 100 is equals to 159 minus 100 is nothing but 59. Very, very important property. This is also very, very important property. Next. Okay, next property, fifth property. This is also very, very important property. If nth term of an arithmetic progression is 1 by n and its nth term is 1 by m, then mth term is always 1 and m plus nth term is nothing but 1 by m plus 1 by m. So observe here, a mth term is 1 by n and a nth term is 1 by m, then a mth term is always 1 and a m plus n is nothing but 1 by m plus 1 by n or m plus n by mn. Observe here, a n is equals to a plus n minus 1 into d. A m means a plus m minus 1 into d. So a plus m minus 1 into d is nothing but 1 by n. A plus d into m, dm minus d is equals to 1 by n. Here also a n is equals to 1 by m. That means a plus n minus 1 into d is equals to 1 by m. A plus dn minus d is equals to 1 by m. This is equation number 2. This is equation number 1. 1 minus 2, we will get a plus dm minus d is equals to 1 by m. A plus dn minus d is equals to 1 by m. If you subtract, second equation signs will be changed. Minus, minus, plus, minus. A get cancelled, dd get cancelled. That means dm minus dn is equals to 1 by n minus 1 by m. We want d. So if you take d as common, d into m minus n is equals to, if you do LCM, this is mn, m minus n. Here m minus n, m minus 1 will get cancelled, d is equals to 1 by mn. If you substitute d value equation number 1, we get a plus d value 1 by mn into again m minus again d value 1 by mn is equals to 1 by n. M get cancelled. A plus 1 by n minus 1 by mn is equals to 1 by n. 1 by n get cancelled. A is equals to 1 by mn. A is equals to 1 by mn. So d is also 1 by mn and a is also 1 by mn. That means common difference is same. Common difference and first term is always 1 by mn. We want a mth term. A mth term is nothing but a plus mn minus 1 into d. If you substitute here a value 1 by mn plus mn minus 1 into 1 by mn. So that is equals to 1 by mn plus 1 mn by mn minus 1 by mn. So minus 1 by mn plus 1 by mn get cancelled. M get cancelled. That is nothing but 1. So mnth term is always 1. And a m plus nth term is a n is equals to a plus n minus 1 into d. A m plus nth term is a plus m plus n minus 1 into d. So here 1 by a value 1 by mn plus m plus n minus 1 into d value here also 1 by mn. That is equals to 1 by mn plus, if you multiply here, m into 1 by mn is nothing but 1 by m plus n into 1 by mn is nothing but 1 by m minus 1 by mn. 1 by mn get cancelled is nothing but 1 by m plus 1 by m. If you do LCM, that is mn, this is m plus n. So if mth term of an arithmetic progression is 1 by n, its nth term is 1 by m, then mnth term is nothing but 1. Mnth term is nothing but 1 and m plus nth term is always 1 by m plus 1 by n or m plus n by mn. Next property. Next, sixth property. Sum of first mth term is, sum of first m terms is n, sum of first m terms. Sum of first m terms is n, and sum of first n terms is m. Sum of first m terms is nothing but n, and sum of first n terms is nothing but m. Then sum of first m plus n term is always minus times of m plus n. Sum of first m terms in arithmetic progression is n. Sum of n terms is m. Then sum of m plus n terms is always minus times of m plus n. We know that Sn is equals to n by 2 into 2a plus n minus 1 into d. That means Sm is equals to n means m by 2 into 2a plus m minus 1 into d is equals to n. If you multiply here 2am by 2 plus m by 2 into m minus 1 into d is equals to n. 2am by 2 plus m into m square into d by 2 minus dm by 2 is equals to n. Okay, if you do LCM, 2am plus m square d minus dm is equals to 2n. This is equation number 1. Also, here Sn is equals to m. That means Sn is equals to m means n by 2 into 2a plus n minus 1 into d is nothing but m. N by 2 into a, that is 2an by 2 plus n by 2 into n minus 1 into d is equals to m. That is 2an by 2 plus n into n square d by 2 minus dn by 2 is equals to m. If you do LCM, 2an plus n square d minus dn is equals to 2m. This is equation number 2. So 1 minus 2, we will get 2am plus m square d minus dm is equals to 2n. Second equation is 2an plus n square d minus dn is equals to 2m. If you subtract second equation, signs will be changed, minus plus minus. So 2am minus 2an is equals, plus m square d minus n square d minus dm plus dn is equals to 2n minus 2m. If you take 2a as common, 2a common, this is m minus n, plus if you take d as common, m square minus n square, m square minus n square. If you take minus d as common, m minus n is equals to, take 2 as common, this is n minus m. M minus n, m square minus n square is nothing but a square minus b square is equals to a plus b into a minus b. Here also m minus n. Take m minus n as a common. M minus n common. Here 2a plus m square minus n square is nothing but m plus n into m minus n. If you take m minus n common, is d into m plus n minus d is equals to 2 times of minus 2 times of, it is m minus n. If you take minus as common, n minus m will be changed as m minus n. So m minus n get cancelled. That is 2a plus dm, or take d as common. That is m plus n minus 1 into d is equals to minus 2. Take d as common, that is m plus n, here minus 1. So m plus n minus 1 into d. Value how much? Minus 2. We want m plus n. M plus n is equals to m plus n by 2 into 2a plus m plus n minus 1 into d. That is equals to, observe here, 2a plus m plus n minus 1 into d. 2a plus m plus n minus 1 into d is nothing but minus 2. Okay? 2a plus m plus n minus 1 into the value how much? Minus 2. So 2 get cancelled, that will becomes minus times of m plus n. Very, very important property. Sm is equals to n. Sum of first m terms is n, and its sum of first n terms is m, then sum of first m plus nth terms is n terms is minus times of m plus n. Very, very important. One example. Yes, 4 is equals to 7. Yes, 7 is equals to 4. Then yes, 7 plus 4 is nothing but 11 is equals to minus 11. Yes, 4 is equals to 7. Yes, 7 is equals to 4. Then yes, 11 is equals to minus 11. That is m plus n. That is minus 11. Very, very important property. Next property. Next. Sixth one. Seventh one. If sum of first n terms is given, that means yes, n is given, then their nth term is, that means a nth term is nothing but a n is equals to sn minus sn minus 1. A n is equals to sn minus sn minus 1. Very, very important property. If sum of first n terms is given, how to find their nth term? A n is not a n. That means a n is equals to sn minus 1. How means Sn means a1 plus a2 plus a3 plus and so on plus an minus times of Sn minus 1 means sum of first n minus 1 terms. So a1 plus a2 plus and so on plus an minus 1. a1 plus a2 plus a3 plus and so on plus an minus a1 minus a2 minus and so on minus an minus 1. Get cancel, get cancel, get cancel. Only it will be there. So an. So Sn minus Sn minus 1. Sn minus Sn minus 1 is nothing but an. Next property. If a1, a2, a3 and so on an are in arithmetic progression, a1, a2, a3 and so on an in are in arithmetic progression, their sum a1 plus a2 plus a3 plus and so on plus an is if n is odd, it has only one middle term, so their sum is n into middle term. N into their middle term. That means number of terms into its middle term. If n is even, if it has two middle terms, their sum is n into, that means n into average of two middle terms. That means it can be written as n by 2 into sum of its middle terms. For example, if n is even, for example,